Welcome to a new class. In this opportunity, we are going to be a little more conceptual and theoretical, and it has to do with explaining how containers work in this working environment based on Ansible, in automation and management of massive instances. As we well know, the fundamental unit in this version of Omniliad's new are containers. We have been working a lot on the Docker Compose part and seeing how Docker Compose served us to orchestrate those containers, provide you with the environment variables, get them up in a certain order, generate certain dependencies, and that whole orchestration makes it so that once the containers are up, our application starts responding. In the Ansible world, and this management that is proposed for the massive management of instances, Docker Compose is not used precisely because, among other things, what is sought is to support other types of deployment formats. We have seen that Ausend we can deploy all in one, but also in horizontal 3-component cluster or in high availability cluster. So that implies that, that Docker Compose don't give the target for that kind of deployments. And on the other hand, an orchestration with a more complex container orchestrator, KS or Apache's, and so many others out there involved a pretty steep learning curve for our users coming from Unileads based on CentOS and oriented to process management, say, by then appeared there shining the possibility of using systemd to orchestrate containers, and that has been very well provided by and documented, at least very well encouraged by the Red Hat people. That is where the Omniliads project was taken to raise this scenario where a container that will implement an Omniliads component is the result of a systemd script that will manage it as a service to that container. So on one side, we have the Postman containers orchestrated by systemd, is a familiar old friend from the CentOS-based Omnily version. So start, stop, Omnily, Postgres, all of that. We extrapolate to this new version, making it a bit easier to assimilate. And there are practically no differences in that sense concerning the Omniliads version based on 107. But while it does have some features, it is good to understand, and it goes through this graphic. Yes, this graphic, I think, summarizes the implementation of podman in systd quite assertively. On the one hand, we have here the container that is launched product of an invocation to systemctl, start, and the component name. But, as we well know, behind each of these actions there is a file, service, that is going to be located in etc systemd system. For each of the Omniliads components, we are going to see that there is a file, service, that is going to have in there, among other things, a run, the execution or the launching of a container. Podman run, like Docker run, serves to launch a container, is parameterized, that container, among other very important things. The network mode on host, as we know, this has to do with using the same network address space as the operating system. We're not going to use Nadio. We're not going to use Bridge. Those container networking modes, because we're in a VoIP-based application, in signaling and media, in different protocols. And all this entails a certain complexity that NAT and Bridge, environments of containerization, make this type of application suffer a lot. So directly in host network mode, this makes it all the more similar to 107 Omniliads. Here we have this item. It is also very critical to understand that each of these files for each individual component is going to be invoked along with its corresponding environment variables file. In this systemd podman format, each component has its own dedicated file. If we look here at a Tessera, default, and here are each of them, unlike Docker Compose, where we had all the environment variables in a single environment point, which we passed to Docker Compose. We don't have that here. Here, each component has its own file, component name, environment, Daphne, 2009, Fehalio, all poor, yes? And in there, well, they will have dissected for him their own variables. That is, we also confine the environment variables that only the component needs. So for example, here we have the asterisk component, the environment variables for the asterisk component, where we saw linking with the previous labs, we have the object storage part for asterisk to move the recordings. And well, this is tied to this other one, system. Here it is. This is the starter, the one that's going to start or it's going to stop. But in the boot, which is what we're interested in now, is alluded to. Then, well, there are some, in some cases more or less some, of operating system directories on the container. And finally, here's passed to you. Here we have the version of the image. 2009, the image. The image of the component and its tag, its version. Then from there I have a systemctl status, asterisk, for example. Neuralgic component of all this. I can it down. And of course, this is going to imply podman PS that the container with asterisk disappears. Start to get it up. So it is a process. At one point, it is a process. Is the word container there, making a little noise, but actually it's a process. There it raised back. The asterisk process consists of CTL systemd. And in turn, as well, this process orchestrator that exists in D also has its counterpart in log management. And that's where we're going to just take advantage also of this systemd to use journald for log management. So I want to see the logs historically or in real time of any of these components. Just is another thing why we leverage systemd, journal, Nginx, or Camalio, or Redis, whichever one we like. See that? We also leverage systemd for centralized log management of the application. Each one of the containers that materializes an Omnily component is going to send the logs to journald, and we can then navigate in the historical ones with journal. For example, I don't know, let's see, X service, and it's the same thing. Podman run. Obviously is another component, another image. It's the Nginx image with its date. We'll do some other mapping of host directories to the container, for example, for the certificate part. And of course, the environment variables. Then ends, for example, which as we well know, is a component that is in charge. No more and no less than of taking all the web requests and distributing them between WebSocket, Camalio, Daphne, or those requests doing reverse proxy and distributing, well, you are going to need, at the level of process, locate to those components. Then I go to the Nginx environment variables, Nginx-M. I will see that, and I have where is Django, where is Daphne, where is Camalio, where is the WebSocket, to where is the bucket. And this, of course, is going to change. This because it is all in one. if this is because all in one, but in other environments, for example, in our environment, all in tree, that of clustering, our clustering environment, where we did a clustering horizontal. Well, if we go, for example, to the part of 1,000 voices, to the voice server, let's see what that variable file of asterisk or nginx, well, it will change a little bit because now it's going to point. Now, because we're going to see asterisk m, let's look at, well, the endpoint of the bucket. But if we look at the endpoint now, for example, how to connect to Postgres, let's see that the address of Postgres is now 101.124.646. Which of this address? The one of our Linux instance that we're going to see here too. Here is the data instance. So now the asterisks process in this cluster environment of 3 components: voice, data, and application. Let's see that, for example, inside the voice server. When I see ready the asterisk environment variables, I'm going to see that it's pointing to the Postgres host, versus what we had here, that if we see, for example, the asterisk em, in this case, notice that the is in localhost. Redis, that is going to use it too, isn't it? Asterisk no longer uses Redis to connect, isn't it? Asterisk connects, it needs to know the location of omniliads that have end in X. Actually, this is nginx. Notice that it pulls to its own IP, the 44. To the Postgres that is in localhost. And, well, to the bucket. In the case of an all-in-3, notice that the poger looks for it in an IP. Looks for it in another IP. The 6 is the one of data. To omniliads that is here. Looks for it the 4. The 4 is the one of application. The host of application. Here. 4, well, here we have them also just declared. 4 is application, 5 is voice, data, asterisks, environment variables for the asterisk that is in this format of all in tree. Here, I am standing in this component in this server, and well, clearly, the environment variables for this systemd process is going to place Postgres in dev this location and omnilets in this other one. That is why the reason to be here of this asterisk m. So, when one does podman, PS is listing all the components of omnilets. How can I handle these components? Consistance? Consist-d, for example, jinx, and in turn, with journal-d, with journal-ctl, u, or uf if I want to see it in real time. I can see precisely if the logs. I can view the logs of my application. 172, for instance. Let's examine what with agent. There we are. We are already seeing asterisk logs. Look how I see the asterisk logs. Agent. Logged in. So, in that way, that method orchestrates the issue of the components and the component logs. all these components. Each of them will send their logs to the journal. This is also a configuration that can be observed when listing the file service, because we'll look with a cat to see what it says here. Standard output, standard error, alt journal, log driver. When we invoke the container, in that way it proposes passage to the container scheme. I think this is personal, very, very pleasant, because, well, we do not change practically the tools. They are still system. They are still known tools. And well, once the component is active, it will receive connections and it will open at the networking level to operate with the rest of the components. Well, always based on these environment variables and in the process launched from systemdem. It's 2009.